Hi, today I'm solving top k frequent elements. Given an integer array nums, an integer k, we return k most frequent elements. You may return the answer in any order. So this is the example 1. K is equal to 2 and nums contains again a list of integer elements here. I should return top 2 most frequent elements. How would I do that? If this was my first attempt, I would start by doing something like calculating the frequency. So here the key would be the number and the value would be the frequency. So 1 appears 3 times, 2 appears 2 times, and 3 appears once. And then sort the frequency in descending order, 3, 2, 1. So I'm going to reverse this just to indicate which frequency belongs to which number, and then I'm going to return top 2. So which elements are associated with top 2? Number 1 and number 2, and that's what I'm going to return. So I can think of one more way to solve this by using heaps. Let's talk about time complexity for this. This sounds like a brute force approach. So it takes big O of n to parse or scan nums and calculate frequency. Sorting would take big O of n log n, assuming that we are using merge sort, but if we are using bubble sort or lesser efficient ones, the worst case is big O of n square. And then I'm returning top 2. So overall it's going to take big O of log n brute force. That's the time complexity. So for heaps, that's a different data structure, and the specialty is that you can maintain the most frequent or least frequent, the topmost or the like the bottommost value. So heap always has a sorted data structure which will help you access either the topmost or the bottommost element in constant time, largest or the smallest element, so here to add an element to the heap, it's going to take big O of n log n, and to access top k elements, it would take a constant amount of time since it's already sorted. So again, here the dominant time complexity is the heapify thing. So constructing a heap, and again it's n log n. We can actually solve this in a much better way by using dictionaries. There we calculate frequency. Again, that takes big O of n, and in the next step we are going to store the frequencies as a list. So all the elements with frequency 1 will be stored as in list index 1, and all the elements with frequency 2 will be stored in list index 2, etc. So I'll construct this list for nums, example 1. So again, it's a list of lists. So any element with frequency 0 is going to be an empty list because nums will have at least one element. So 3 goes here because it appears once and it's stored in index 1. 2 goes here and 1 goes here respectively. Okay. And then what I'm going to do is I'm going to get the most frequent element. How do I get the most frequent? I'll just look at this list from the opposite direction, from this direction. So since the index is more as we approach right, we'll be storing most frequent elements in the right. So again, we'll scan from the right and store up to k elements in the output list and send it. And let's talk about time complexity again. So it takes big O of n to calculate the frequency and big O of n again to construct this list, and big O of k, where k is the most highest value it can take is the number of unique elements. So in worst case it can reach up to n. So the dominant time complexity is big O of n again. So let's code this up. Okay, for each number in nums, I'm going to have a default. I'll just get a default length. So I'm parsing nums, and then if number is not in counter, I'll add counter of num plus equals 1. So just to know what the counter looks like, I'm just going to print it, and then yeah, it has 1 1 2 2 3 3. Oh. Yeah, 1 is 3, 2 is 2, 3 is 1. Okay. Since I was using default ticked, I don't have to check if a number exists, and it's handled by this default ticked object. It's going to make my life easier, so that's why I used it. And let's access all the items in this dictionary. So when I do counter.items, I'll have the key stored in the variable key, value stored in this, value stored in the variable value, and it's going to go through every single key pair or key value pair of the dictionary. So sorted 0. So I'm just going to add elements here. And so I'm calculating the length of the number, and then I'll do n plus 1. That's because the index starts from 0 in arrays, and I wanted to reach up to the maximum amount of frequencies we can get in the test case is, let's say there's just one number and the frequency will be equal to the length, so it can reach to that number at max. And let's see if this works. I like to print it. I spelled it wrong, I fixed it. Okay, this is what the sorted frequency would look like. And let's continue coding. So the sorted frequency of key okay, so we will store the number in the frequency. So value is will take on the role of the index for a sorted frequency. For example, here key is 1, value is 3. We are going to store 1 in index 3, right? So in index value we are going to store key. And we can look at the updated sorted frequency. And then we just need to return the top key elements. And I have used an extra data structure called list to store whatever I'm going to send in the output. So we are going to go in the opposite order of sorted frequency. We're going to start from accessing from the last index. So for I in range of n, minus 1, minus 1. If sorted frequency of I, then we're going to put dot next in. Then we'll return output k. So this I'm using slicing. I wonder what's wrong here. Oh, I was not returning. That was the error. Shit. Oh, sorry about that. Oh god. Okay. Mm, yeah, it's decent, but I want to see how top people did it. How they sorted the top K and top K frequent. Okay, counter nums, yes. They've used Heap Q and largest. Okay, so I think I need I need to drink some coffee to understand this. Oh, okay. Yeah, I give up. I maybe look at this later. But yeah, I'm having fun posting this, and I learned something new today, and I hope you did too. Thank you.